4.6, solving quadratic equations by completing the square. We're going to complete the square in the standard form and vertex form. We'll have two different types of situations. All right, so when we're completing the square, we're going to have to remember how to use the square root property. Recall when solving equations involving a square, we had to undo that square by taking the square root. When we do this, we must use that plus or minus to account for the positive and negative roots. Again, that was a square root property. So whenever you do this and you solve these, remember there are two answers, one positive, one negative. So whenever you're solving with square roots, it will be plus or minus in front of that. All right, so like for instance, we have x squared equals 25. Well, we've learned that to undo squares, we take the square root. So if I was to take the, let's see, get a color here, the square root of this side, I have to take the square root of that side. So when I do that, this little 2 in the index here and this 2 exponent, they essentially cancel each other. So this will just leave x is, and remember because we're solving using square roots, it's a plus or minus. And then what's the square root of 25? Well, that's 5. So our answer is positive 5 and negative 5 will both work because 5 times 5 is 25, and negative 5 times a negative 5 is also 25. That's why it's both positive and negative. All right, over here, I'll get a different color because I don't know that you can see that as well. When we take the square root of both sides, it stays the same. Hold on. When we take the square root of both sides, there it's a little bit better. Okay, square root. We have x equals, but we have the square root of negative 25. And we have just learned that taking the square root of a negative number means that it produces that little I symbol. Right, so this is going to be a plus or minus I something. And then that takes care of the negative, and now what's the square root of 25? Well, that's 5. Most of the time you'll see this written as x is equal to plus or minus 5i. They usually put the 5 in front as a coefficient. Okay? All right, and then this one, we have this whole thing being squared. Well, we can take the square root of that and get rid of this little square. And if we do that, we have to do it to both sides. Well, when we do that, all it leaves is just x plus 2. Nothing else. There's nothing else we need to do, just x plus 2. That is equal to plus or minus because we're taking the square root of a number, and that is going to be 5 over here, right? Then the last thing you do is you solve for x, so you subtract 2. Subtract 2 again, so that's x is equal to, and then I'm going to put this right here in front, minus 2 plus or minus 5. Now, because those are real numbers, we can finish that out. X would then be, what's negative 2 plus 5, and then x would be negative 2 minus 5. Well, negative 2 plus 5 would make x is 3. And then negative 2 and negative 5 make x is negative 7. So this one had two answers, just like these did, but they have to be split up. If you can split it up and simplify it, you must do that. So the answers are negative 7 and 3 on this particular one. And you can plug them back in. That's the nice thing about it. You can plug these in and check them. If I put a negative 7 right here, negative 7 plus 2 is negative 5. Negative 5 squared is 25. So that checks. If I put a 3 in there, 3 plus 2 is 5. 5 squared is 25. So you can see they both work. And you can check your answers anytime you want to. But you have to make sure that if you need to simplify it, you can and must do it. You won't see it left like that. We will be using this process when we do this thing called completing the square, which will create a perfect square trinomial. You'll see me talk about PSTs, that's perfect square trinomial, that we will be using to solve those quadratic equations. So, before, when we had a problem like this, x squared minus 6x plus 9, we could factor this because we could say factors of 9 that add to be 6. Well, that would be 3 and 3. Okay, and then I'll look at the signs. The signs have to be the same because there's a plus in the back and they both have to be negative. So that makes x minus 3, x minus 3, which is, most of the time you'll see it as just x minus 3 squared. This makes a perfect square trinomial, okay? Because this was a perfect square, and this was a perfect square, and it worked out. Remember, these are the ones I told you have to watch, and sometimes they don't work, but these work. So when we're doing complete the square, we're trying to make a perfect square trinomial. So what value would complete this particular problem? X squared minus 10x plus something will make a perfect square trinomial. What do you think you would do? What do you think we did here? We had a negative 6 and we had negative 3 and negative 3. So what do you think we'll have here? We'll probably end up with a minus 5. So I'm thinking x minus 5, x minus 5, which would make x minus 5 squared. So that would make the number that had to go in here, if you did 5 times 5, that would be 25. So what you're really doing when you're finding that perfect square and trying to find that combination, you're taking the linear term, the middle term, and you're dividing it by 2, which is 5, and then you're squaring it to give you that number that goes in the back to make a perfect square trinomial. So remember this, you divide the number by 2, then you square it, and then you put it in the little blank. You'll be adding this 25 to both sides when we complete the squares, okay? All right, now let's go ahead and get started on them. When we're solving equations by completing the square, the quadratic needs to be in standard form. Remember, again, standard form, ax squared plus bx plus c equals 0. That's your standard form. Should know that by now. Or have the c on the other side. So we can, as long as we have the x squared, the quadratic term, and the linear term on the left, if the constant term's on the right, that's going to be okay when we complete the square. If not, we're going to make it that way anyway. The leading coefficient, which is the coefficient of the quadratic term, okay, that's the a, has to be only 1. And if it's not, then we need to divide all the terms by that number. Okay? If it's not already there, we need to move the c to the right side. Okay? Divide the coefficient of b, which is the linear term, by 2, just like we did before, and then take that answer and square it, and then add it to both sides. On the left, you're now going to have your PST, or your perfect square trinomial, that you can factor with the parentheses and something squared. By solving with that, you're going to be using the square root property, which means you'll take the square root of both sides to solve for x. So let's start with some of these and see what we can get done. If we take our linear term, okay, this one right here, in order to find the number that would complete the square, remember we take our linear term and divide it by 2. A divided by 2 is 4. And then we take that number and square it, which makes 16. So 16 would go there. Okay? This one, and notice I'm not worried about whether it's positive or negative. That doesn't matter. You just take the middle term, divide it by 2. You don't have to worry about negatives and positives or anything like that because you're always going to be adding to get a perfect square trinomial. All right, so this one I'm going to take 7 and I'm going to divide it by 2, which is 7 over 2. because that doesn't simplify. And then I'm going to square that, which makes 49 over 4. Don't forget, each thing inside the parentheses must be squared. So that's 49 over 4. Okay? All right, the next one is 3/5. And there should be an X right there. Sorry, I noticed it after I made this. Should be an X right there. So the linear term is 3/5. So you're really doing 3/5 divided by 2. Well, we know we can't divide by 2. That's illegal. So what do we do instead of dividing by 2? That would be the same thing as 2 over 1, right? So we can flip it and multiply. So that makes 3/10. All right, so when you're dividing a fraction by 2, it's the same thing as multiplying by 1/2. All right, so then that makes 3/10. Well, then we square that, which makes 9 over 100. So 9 over 100 is the number that goes in the blank. Okay, so be careful when you have fractions. You can't really technically divide by 2, so you really need to think multiply by 1/2 and then square that number. Okay? All right, let's practice some of these problems, completing the square and solving. All right, let's start with 1. Remember, the first thing you want to do is make sure it's in standard form. This one is. It's got the x squared and the x and then the constant. The next thing you want to do is move your constant over to the other side. Now when I do, I'm going to leave a plus blank here because I'm going to use it for something else in a minute. But when I move that 4, I got to subtract it from both sides. So that's gone. So now I have a -4 over here. Okay? Now I'm just going to look at this side right now. Okay? I need to complete that square and make it a perfect square trinomial. So I'm going to take my linear term and divide it by 2. So it's going to be 6 divided by 2, which is 3. Square that and add 9 to both sides. Okay? When you do this, what happens when you factor this, you're going to end up with x minus 3. So whatever's right here, you're going to keep that in your parentheses. It's going to be, this number is going to go right here. So whatever you divide by is going in the parentheses. 6 divided by 2 will go right there. You want to write and build your steps at the same time, that's fine with me. I do that a lot myself. So I just know that it's going to be an x minus 3 thing going on here, because when you do x minus 3 times x minus 3, you're going to get this right here. Equals. Okay, and then this is -4 plus 9, which is +5. All right, now it's back to solving for x. And we notice that we've got a square. And we just did problems where we had to undo squares by taking the square root of both sides. When we do that, we're going to end up with just x minus 3 over here. But we're going to have plus or minus because we are doing, taking square roots, square root of 5. Okay? Because this happens to be simplified. If it's not, you have to simplify as you go. Last step, we want to solve for x, we just move that 3 over. Now, when you move something over to this side, generally speaking, it goes in front of your plus minus. So I'm going to put it right here by adding 3 to both sides. 3 plus or minus the square root of 5. So that will give you your answer in simplest radical form, which is what they're going to ask you for. All right, so that one's done. So if this will become a decimal, and you will be able to see that on your calculator, but when you're finishing the problems up, most of the time the standardized test will have this kind of answer, not the decimal. All right, so let's try another one. All right, this is x squared plus 14x plus 50 equals 0. I need to have it in standard form, which I do. Next step is I need to move this 50 to the other side. So that's going to leave me with x squared plus 14x plus something we don't know yet equals, when I move it, remember it changes signs. Okay? All right, so the next step is going to be take the middle term divided by 2 and then square that. So 14 divided by 2 is going to be 7. And I'm already going to build my problem down here because I know that's what's going to go in the parentheses. All right, 14 divided by 2 is 7. 7 squared, don't forget that part, is 49. And you add that to both sides. Now the one thing about complete the square, it just takes some time to do. We haven't done anything like this before, so it's just going to take practice. So you're going to have plenty of chances to practice on this, but I do recommend doing the problems, doing as many of these in-class problems as well as your homework, because that'll be about all the practice you'll get before you have a test or quiz. All right, so x plus 7 is now built, equals, and then negative 50 plus 49 is negative 1. Taking the square root of both sides is going to make just simply x plus 7 over here. Okay, because this square and this 2 in the index, they cancel each other out. So there's no parentheses, nothing. All right, is equal to plus or minus. Now, square root of negative 1 we've learned is I. So this is now plus or minus I. Okay? Last step is solving for x. We're going to subtract 7 from both sides. So x is going to be negative 7 plus or minus I. So this is imaginary. So this would be like one of those parabolas where instead of crossing the axis, it's going to be hanging up here without crossing anything, okay? That's what these answers do. So remember, I told you it wouldn't be anything that would be no solution anymore. As far as factoring goes, we wouldn't be able to find all the answers now, okay? All right, next problem. Check to see if it's in standard form. It is. Then we need to move this 3 over to the other side. So I'm going to have x squared plus 4x plus blank equals negative 3. Okay, and then I want to take the middle term, divide by 2. So that's going to be 2. So I know it's going to be x plus 2. That'll be squared. And remember, I bring down whatever sign's right here. I bring it down right there. And then I continue. 4 divided by 2 is 2. 2 squared is 4. So I add it to both sides. Equals. All right, what's negative 3 plus 4? That's just 1. So then take the square root of both sides. And you're going to get x plus 2 equals the square root of 1. Don't get fooled. What's the square root of 1? Well, that's just 1. Okay, that's plus or minus 1. All right, so then subtract 2 from both sides. That's going to be, I'm going to put it up right here. That's going to be x is equal to negative 2 plus or minus 1. Well, that can't be left like that because you can break that apart. You have x is negative 2 plus 1, which is negative 1, and x is negative 2 minus 1, which is negative 3. So these are your answers. Again, you must finish it. If you can simplify it, you have to do it. All right, so now the last problem, it's in standard form. Okay, but there's a coefficient that's bigger than 1. We have to get rid of that, and we also have to move this negative 4 over. So this one is going to be, I'm going to go ahead and just write everything in little steps. Plus blank equals 4 over here. Okay, all I did was move my constant. Now, I have to divide everything by 9. So that leaves me with x squared minus That's going to be 2/3 when you simplify it, plus blank equals 4/9 doesn't simplify. Now, we have to then continue completing the square. We have to take this fraction and divide it by 2 or multiply by 1/2. So that's going to be 2 times 1 is 2 over 6, 2/6, which makes 1/3. So that's going to be, in my parentheses, x minus 1/3. And don't forget, I have to take this 1/3 and square it, so that's going to be 1/9. Add that to both sides. So that'll equal 4/9 and 1/9 make 5/9. I think I'm going to run out of room. All right, so when you finish this and take the square root of both sides, you're going to end up with, I'm running out of room. Let's see if I go up here and erase some stuff so I can finish my problem. Okay. So I'm going to move this up here. So I'm going to end up with x minus 1/3 equals plus or minus the square root of 5/9. Okay? Alright, so I need to clean this mess up because it's 5/9 under the radical. And I know that I could split that up and make square root of 5 over the square root of 9, which makes 3 on the bottom. So let me go ahead and write that. X minus 1/3 equals plus or minus square root of 5 over 3. Alright, and then add 1/3 to both sides. So I'm going to have x is equal to 1/3 plus or minus the square root of 5 over 3. Now, sometimes you will see this. This was a long problem. Right up there. Sometimes you will see this written as x is equal to 1 plus the square root of 5 all over 1 plus or minus the square root of 5 all over 3. That's the same thing. You see it this way or this way, it's the same thing. Because the denominator for both of these was 3, you can just put it down underneath there and then put 1 plus or minus square root of 5 on top. Okay? So again, when you are doing these and they have a coefficient bigger than 1, you have to divide everything by that coefficient before you get started. Oftentimes that'll give you fractions, which can be a little bit cumbersome, but you can do these without any problem. Okay? And then you get an answer like this, which is definitely a decimal. Alright, so now if we want to go into the vertex form, they're going to be, remember, we've used this before, y is equal to a times the quantity of x minus h squared plus k, where k was our constant. It was actually our y coordinate, the h was the x coordinate of a vertex, and the a was the slope, remember? So when we were finding the vertex, we did the opposite of what was inside of the parentheses, and then k was the other part of it. So we're going to be finding that vertex also when we do these. So you're going to solve by completing the square very similarly, but instead of moving the c to the right, you're going to move it to the left, behind the y. And you'll notice that these, you'll be able to tell which ones need to go in vertex form because they will start with either y is equal to or f of x is equal to. Okay? They won't have equals on the right side. They will have equals on the left. So you'll know exactly what to do when you see that format. So we're going to move the constant to the left and complete the square on the right. And if you have a leading coefficient greater than 1, you have to divide everything. But the one difference is if you have to do any dividing, whatever you add to both sides you would then have to multiply by whatever you had to divide by. I know it sounds really complicated. It's easier when you see what we do with it. Just know that it's a little bit different in that way because you have to multiply it to the left-hand side, to the number you moved. All right, so then when you finish this though, you will not solve it. You will instead have a y equals problem, just like the vertex form up here. So when you finish it, it'll be y something, and then it'll have the constant term put in the back of your parentheses, okay? So then you can find your vertex. You can also check your answers by graphing these. Anytime you have it like this, and then you put it in vertex form, you can check to see if it's the same graph, and I'll show you how to do that with the calculator in just a second. But let me show you how to do one without the coefficient that's bigger than 1, and then one where it is. All right, so what you're going to do is you want to move your constant. It's got to go over here behind the y, so I have to change the signs because it's crossing the equal sign. So that will be y minus 32 equals x squared minus 10x, and then here's where you put your plus blank. Okay? You're going to be completing the square over here, so this 10 will be divided by 2, which will be 5, so it's going to be x minus 5, and then square that. 5 and squared is 25. So I would be adding that 25 over here. So I'm going to now have y minus 32 plus 25 is equal to all that. Okay? So now what is negative 32 plus 25? Let's check that out. I believe it's a negative 7. Now let's just double check. Negative 32 plus 25. Negative 7, so this is now simplified to y minus 7 equals, and then this stayed the same. Alright, and then the last step is to move this minus 7 over, and it goes in the back of this. So this is going to be y is equal to parenthesis x minus 5 squared, and that's going to be a plus 7. So this would be your answer form. So that would mean your vertex would be opposite of what's inside, 5, and then whatever's in the back, 7. Now, let me show you how to double check this on your calculator, because I think these can get confusing, and you're trying to do all your other work, it could be really confusing. Alright, so say I want to check to make sure I did my work right, okay? I'm going to go to y equals, and I'm going to type in the original equation, so that's going to be x squared minus 10x plus 32. Okay, that's the original. Then I want to see if what I wrote is the same thing, so I'm going to put parenthesis x minus 5, and I'm going to square that, plus 7. Now, if it is the same and it's the same exact thing, just in a different form or simplified or factored, when you graph it, it should only make one parabola. You have to wait till this is finished over here. So I'm going to zoom out so we can look at it. Alright, there's the first one, and it's still going. Alright, so it's only one U, so I did it right, okay? That's how you want to check these, to make sure you did it right. If it's only one U, now if you had another line over here, whoops, if you had another line that's written, over here, or 2 U's, 2 parabolas, then it's not correct. So if it's not correct, you need to go back and redo it. Alright, so that's how you check with your calculator. Now, let's do one where the coefficient is bigger than 1, okay? Let's see, I'm going to use white. Alright, we still need to move the k over to the other side. Okay, so that's going to be y minus 5 is equal to, I'm going to leave some space this time so we can see it all. 3x squared minus 12x plus blank. All right, again, you have to divide everything out, take out a 3. So we're going to take out a 3, we're going to factor it out like a GCF. So this is going to be 3x squared minus 12 divided by 3 is 4x, and then put your blank. Okay? Still haven't done anything with this side, so we'll just leave it alone for now. All right, so now we are going to complete the square with what's inside, right here. So the linear term is 4, so I'm going to divide it by 2. So that's going to make 2. So this GCF comes down, x minus 2 squared, all right, and then square that back in, so that's going to be 4. Okay? So all I did was I GCF'd out the 3. Whereas we divided before, we're still dividing, but it looks a little bit different. Okay, we're dividing out of the parentheses. And I did 3x squared divided by 3 gives me x squared, and then negative 12x divided by 3 is a 4. All right, then I can complete the square because now the coefficient right here is a 1. This is the GCF. This has to be brought down. This is what changes the slope or the steepness of the parabola. And yes, it's very important, as we've seen before. If you don't have it, it changes the entire problem. All right, so now I have over here y minus 5, and I'm going to add this 4 to both sides. Okay, but whatever I add, because I took out a 3, I must multiply it to that 4 only. Okay? So that's going to be y minus 5 times y minus 5 plus 12, because when you multiply 4 and 3, you get 12. So negative 5 plus 12 is going to be a 7. So it's y plus 7 equals this. And then to finish it, you move the 7 back over to the back. So I'm going to write it up here. So this should be y is equal to 3x minus 2 squared and then a minus 7. Alright, so that makes my vertex to be opposite of this, which is 2, negative 7. Alright, now, again, you want to check these with your calculator just to make sure you've done it right. Alright, let's pull it back up and move it out of the way. Alright, so if I want to check it, I'll go to y equals, and I'm going to put in the original, so it's 3x squared minus 12x plus 5. And go to the next one, I'm going to write down 3 parentheses x minus 2 quantity squared minus 7. And let's see when we graph that. There's your first parabola. And remember, when this is finished over here and you only have one parabola, you've done it right. So this one is correct, okay? Let me just show you what it looks like if I messed it up. Say I put, go down, whoops. Let me go down here and scoot over. And make that a 9, okay? Let's see what it looks like. There's my first parabola. And you see how it had 2? Because that means it's not the same. So when you have it exactly right, it will be one parabola only. Okay? Again, I'll graph it so you can see it. And when this is done, it's done. 1. And it's 1. Okay? Alright, so that's how you can check with your calculator. Any of your factoring type problems. I believe that is it. So we will practice more in class. But yeah, definitely check your answers with your calculators. And if you have any problems, come see me. We'll do lots of practice in class. See you in class.